friends, thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions to sequence and series. The subtopic before us is geometric progression, that is GP, or exponential sequence. With us here is example 4. In my previous video, I've solved example 1, 2, 3. Let's look at example 4. We have Roman numerals 1 and Roman numerals 2 under example 4. Roman numerals 1 read, the sum of the second and the third term of a geometric progression is 6 times the fourth term. We are asked to find the two possible values of what? The common ratio. Roman numerals 2, if the second term is 8 and the common ratio is positive, we are asked to find the first 6 terms of the GP. The questions are the same in the sense that you have to use the solution here in Roman numerals 1 to solve Roman numerals 2. Let's write down the solution and see how we can analyze this. Let's write down the solution and interpret the question. The sum here, when we say sum, that's addition. Sum of the second term and third term means whatever our T2 is plus T3 is equals to 6 times the fourth term. We're not using sum of GP formula here, no. It's just the word sum we add. So it means first we need the nth term of GP. The nth term of what? Nth term of GP is given as term now equals to the first term multiplied by the common ratio power the number of terms minus 1. The excess is so that we can get T2 when second term means n is 2. When we substitute n equals to 2, what are we going to have? That will be T2 now will be equals to AR power 2 minus 1. That's 2 minus 1. That will be AR. That will be AR. So T2 is AR. What will be our T3, the third term? T3 now will be equals to AR power 3 minus 1. That will be AR power 2. So this is our third term and this is our second term. So we are told that the sum, meaning T2 plus T3, the sum of the second term and the third term of geometric progression is equals to 6 times the fourth term. That will be 6 multiplied by T4. That's what it means. That's the interpretation. It means we need to get our T4. T4 now will be equals to, we substitute n equals to 4 into this. That will be AR power 4 minus 1. That will be AR power 3. So T4 is AR power 3. Okay? We are told that this interpretation here, we'll use it to find the common ratio as well as the first term. Very important. But the question says, find the possible value of the common ratio. Let's click here to see how we can find the possible values of the common ratio. Very important. Let's substitute this T2. Our T2 is AR. We substitute now. That will be AR plus T3 is AR squared. AR squared will be equals to 6 times T4. T4 is AR power 3. Very important. Let's transfer everything because this is a cubic equation. The highest power here is 3. Let's transfer everything and equate it to 0. This will be 6 AR power 3. We transfer this to the left, to the right, we transfer this to the right. That will be minus AR power 2 minus AR will be equals to 0. Okay, by observation, we can see this clear that AR is common. So we can factor it out. AR out now, 6AR cubed divided by AR will be left with 6R squared minus, if we factor AR here, we'll be left with R. If we factor AR, that's AR divided by, we'll be left with minus 1 will be equals to 0. Very important. So it means either AR is equals to 0 or 6R squared minus R minus 1 is equals to 0. Let's move here to interpret that. So we can say that either AR is equals to 0, let's call this equation 1, or 6R squared minus R minus 1 is equals to 0. It means at this point, we can find A. A will be 0. If we divide through by R, it means A will be 0 and R will be 0 from this equation 1. A and R will be 0. But let's use equation 2 and see. This is quadratic equation. Two factors of 6 that can give us minus 1, that's minus 3R and plus 2R. If we are to factorize this will be 6R squared minus 3R plus 2R minus 1 will be equals to 0. Realize that the middle term, of course, will give us minus R. And when we multiply this, we get minus 6R squared. So, next thing, let's group this. Our aim now is to find the possible value of R. That is the common ratio. Let's group this. Let's group this. What is common here is 3R, bracket open, 6R squared divided by 3R, be left with 2R, minus 3R divided by 3R, that will be 1. We close the bracket. What is common here is, of course, is plus 1 into 2R minus 1 is equals to 0. So what we have inside the bracket are the same. We'll pick what we have outside. That will be 3R plus 1 in one bracket. Then bracket open, 2R minus 1 equals to 0. Very important. So at this point, either 3R plus 1 is equals to 0 or 3R minus 1 is equals to 0. So 3R plus 1 equals to 0. R now will be, if we bring this, it will be minus 1 divided by 3, or 2R minus 1 equals to 0. What will be the value of R? Okay? We are looking for the possible values of R. First R now. R is what? Let me do it well. Let me take it here. Let's collect like times. That will be 3R will be equals to minus 1. We divide both sides by 3. Our first R is nothing but minus 1 divided by 3. Or we have 2R minus 1 equals to 0. This will be 2R equals to, we'll bring this minus 1 to the other side, it will be plus 1. We divide both sides by 2. R now is half. So these are the two possible values of R. R is minus 1 divided by 3, or R is half. So we are through with Roman numerals 1, because we are asked to find the possible value of the common ratio. The possible values are R minus 1 divided by 3 or 1 divided by 2. The Roman numerals 2 now, if the second term is 8, if T2 is 8, let me clean here. If T2 is 8, T2 means if we use n term, solution to Roman numerals 2 now, nth term is giving us this. If n is 2, what are we going to have? 2 minus 1. T2 now will be AR. But we are told if AR, which is T2, AR is equals to 8, and the common ratio is positive. So between these two values of R, which one is positive? When R is half. Okay? And when R is what? When R is positive number, which is half now, we are asked to find the first 6 terms of the GP. Okay? Here, R is giving us half. We are using the positive R, which is half now. So let's find the common, the first term. If AR is equals to 8, given that R is half, let's substitute. This will be A times half will be equals to 8. A times half is A divided by 2 will be equals to 8. Let's cross multiply. A now will be equals to 2 times 8, which is 16, given that common ratio is half. We are asked to find the first 6 terms of the GP. The first 6 terms of the GP now, we have to generate. Very important. First term, which is A, second term will be AR, third term will be AR squared, fourth term will be AR power 3, 1, 2, 3, 4, fifth term will be AR power 4, the sixth term will be AR power 5. Okay, so we are asked to write down this, given that A is 16 and R is half. So first term here is 16. Second term will be 16 times half. That's 16 times half. That will be, of course, 8. Okay, then what will be the third term? We substitute. Let me do the substitution up here to get the third term now. First term is 16. That will be 16 times half all square. This will be 16 times 1 divided by 4. 4 here, 1, 4 here, 4. So third term will be 4. The fourth term now, A is 16 times 1 divided by 2, all in power 3. Of course, this will be 16 times 1 divided by 8. 16 divided by 8, of course, will be 2. The fifth term now, the fifth term, let's get the fifth term. A is 16. A is 16 times 1 divided by 2, all in power 4. This will be 16 times 1 divided by 16. That's 2 power 4 is 16. 16 divided by 16 is 1. The last but not the least is the sixth term. Given that A is 16 multiplied by R, which is half, all in power 5. This will be 16 times 1, that's 16 divided by 2 power 5 is 32. 16 here, 1. 16 into 32, that's 2. Let's check. This is 12, yes, that's 2. That will be a half. So we are asked what? Find the first 6 terms of the GP. So the first 6 terms of the GP are 16, 8, 4, 2, 1, then half. So these are the first 6 terms of the GP. So this is the solution to Roman numerals 2. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. Thank you for watching. See you in my next video.